can finish it. Okay. So first of all, you got to look at this the right way. It's always kind of looking at the big function and then kind of what's nested inside, because we're talking about the chain rule. So if you look at the big function, you have what? Something to the third power, right? Okay, the idea is you kind of got something like y equals u to the third, like that. And then inside of that, u would be just this part right here, like that. Okay, now you don't have to write down the y and u part, but it's good to kind of think of it that way, because the chain rule, what the chain rule is basically going to tell you to do is it's going to tell you to do this. It's going to tell you to do this derivative, the derivative of that first, and then multiply it by the derivative of that inside part. Okay, so how do you do a derivative of u to the third? What is it? 3u to the second. So we start that way. We start when we do this, I'll just say dy over dt now. So we're going to bring the 3 down like that, and then we'll leave the e to the t over t minus 1 alone and subtract 1 from the exponent. Okay, but we're not done, because you still have that inside part to do. So the chain rule then says multiply by the derivative of the inside part, and that inside part is e to the t over t minus 1, like that. Okay, that's how you start it off. Okay, all right, so what you need to do now is you got to think, okay, how do I do this derivative? How would you do that derivative? That's a quotient rule, right? Okay, so I'm just going to write the quotient rule at the side here. That's the one that goes bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, you don't need to write that down, but you need to refer to it as we go through this then. So we're going to do this, and you just keep bringing down that first part. You still got e to the t, t minus 1 squared. Now let's put this in the quotient rule. Okay, so when we do this, you're going to have the bottom, which is t minus 1. Okay, what is the derivative of the top? E to the t. Okay, derivative of e to the t is e to the t. We've got that. Okay, then you do minus, and then you do the top. Okay, what's the derivative of t minus 1? 1. Okay, so see, you can do those pieces in your head when you can, and then you go all over the bottom squared like that. Okay, so see, the calculus is already done. The rest of it is the algebraic simplification. That's the part usually students have more trouble with, is that part. So do you guys see what I've done so far? Okay. Okay, so you're doing a chain rule. You're doing something to the third power. That's why you're bringing the 3 down, subtracting the 2. But then, by chain rule, you have to multiply by the derivative of what's inside. Okay? Now, let's see what algebraic simplification you can do. If you look at this part right here, you got two choices. You could distribute the e to the t through, or you could factor an e to the t out. It doesn't make any difference, really, which way you approach that. So I'm going to go ahead and do this like this. So I'm going to have 3 e to the t over t minus 1 to the second for now. And then let's go ahead, let's factor out an e to the t. Okay, you need to develop the habit of factoring stuff out. So just look at what I highlighted here. This is a common factor. Okay, now watch this carefully, because this is where students sometimes do not do well. You're going to take that e to the t out. Okay, like that. Okay, now if you block that off, all you got to do is just block this off in your mind. Tell me what's left. T minus 1 minus 1, right? Okay, you're taking that out. So then you can write that t minus 1 minus 1 like that then. Okay, so we have that. All right, and then we still have all over the bottom squared like this. Okay, so we have that. Something's happening with my pen here. I'm going to close this just real quick. I think it's this connection's a little funny today. Okay, let's see if I can stop doing this dark or something. There it goes. Okay, so what I'm going to do from here, let's kind of finish this up. And inside the bracket, of course, you got like terms that you can put together. So from here, I'm still going to have this. Now, one thing that you want to do on this part right here, anytime you have a fraction to a power, you can do both the top and bottom to that power. So you want to go ahead and write this as 3 times, and then you can write this as e to the t to the second, and then all over t minus 1 to the second. That's something that you want to make sure you know how to do, okay? All right. Now, what do you see that you can do inside the bracket here? Really, all I see is those are like terms, so you can put them together, okay? So if you do that, you're now going to have this, and I'm going to actually break this up kind of like this. So what I've got left now is I've got e to the t times t minus 2, okay, all over t minus 1 to the second like that, okay? Now again, we're dealing with algebra right here. So what I have done so far after the calculus step is I'm just saying, okay, that's to the second, that's to the second, and then I've just basically combined the like terms. Do you guys see what I'm doing? Okay, because this is what you got to get into now. Now, there's one other thing that you can really do on this problem. And really only a couple other things I see. What can you do with that? Add the exponents, right? Okay, that's t minus 1 to the 4th. It's the same thing multiplied by itself, really. Okay, so you can write that as t minus 1 to the 4th, like that. And the other question I have for you is, what can you do with this? If you have a power to a power, do you know what to do on that?
Cancel it out?
Nope, multiply the exponents. Okay, like if you had something like this, say there's little algebra issues. If you had x to the second to the third, that's x to the 6th. Okay, that's something you've done before. You need to recognize it. So what you would end up having is 3e to the 2t, okay, times e to the t times t minus 1, t minus 2 like that. And then there's probably one other little thing you could do. So I have that. And then this part right here, okay, do you know what you can do with that? What if you had this? What if you had x to the 3rd times x to the 4th? What's that? X to the 7th, okay? You can add those exponents together, okay? A lot of times students don't recognize that because it looks different than this, but it isn't, okay? So what you would end up having for your final answer is you would have 3e to the 3t, 2t plus 1t is 3t, then you'd have t minus 2 all over t minus 1 to the 4th like that. That's it. And that's your goal, is to get all the way to the bottom like that. And you notice that most of that problem was not calculus, most of it was algebra. Okay? So is there anything that you don't see with what I did algebraically? Okay, you got to spot stuff like this, and mainly it was a lot of properties of exponents and that factoring. And the factoring is where students struggle on this most of the time. Okay, is there any questions on that? Okay, because you don't want to just stop at that calculus step. See, we were already done right there with the calculus. The rest of it's algebra. Okay, all right, let's do this next one. And I did one like this in the last class. So first of all, what you want to see on this problem, you always got to look at these problems the right way. I see two functions, and I'm trying to box those in. Those are two functions that are multiplied. So what rule do you use if you have two functions multiplied? The product rule, right, okay? So we're going to have the product rule and the chain rule in this same problem. So the product rule goes like this. It's the first times derivative of second plus second times derivative of first, okay? So we're going to go ahead and get this kind of put together. Okay, now what you want to do is you want to write this, down kind of like this. So we're going to have, when we do dy over dx for the derivative, you want to get everything put in, so you want to write down the first, and then let's write down that we're going to do the derivative of the second before we do it. Okay, then plus, and then do it backwards, write down the second. Okay, and then write down that we're doing the derivative of the first like that. Okay, that's what you're going to do in the problem. Okay, get it set up before you do anything with it. So I have first derivative of second plus second times derivative of first. Okay?
Did you forget the square on the 2x minus 5?
I may have, yeah. Okay, yeah, sorry about that. That's a 2. Okay, now I'm good. Okay? All right, now let's do this. So we've got to do that derivative and we've got to do that derivative. So how do you do, remember we learned the general power rule. So what did we do? You bring the 3 down, subtract from the exponent, and then you have to multiply by the derivative of what's inside. Okay? So watch this part carefully. Okay, so I'm going to bring this down. That's 2x minus 5 to the second. Okay, this part right here is that I highlighted in yellow is going to be 3 times x plus 1 to the second. And then you got to do the derivative of what's inside. So what's the derivative of x plus 1? 1. Okay, if you forgot to do that, it wouldn't matter, but really that's what you're doing. Okay, then we bring down the x plus 1 to the third. Okay, and let's do this carefully. So you bring the 2 down. The 2x minus 5 you don't touch. That would go to the first power. What's the derivative of what's inside? 2. There you go. Okay, calculus done. Okay, product rule, and then chain rule is embedded within that. Does that make sense to everybody? Okay, now here's the algebra. Here's the part where you got to really work on. Now what I'm going to do is I'm going to kind of clean this up. You really have 2 parts of this problem. You have this part, and then you have this part right here. Right, now I got a couple of things I can do. I'm just going to write one more step, although you could bypass this. I'm going to write this first one as bring the 3 in front. 3 times 1 is 3. Then I'd have 2x minus 5 to the second times x plus 1 to the second. And then here I've got 2 times 2 is 4. And I've got x plus 1 to the third. And I'll keep that 2x minus 5 to the first, keep that first power just to emphasize. Okay, so I'm cleaning it up. Okay. One thing that I think would help students who struggle with factoring is if you do what I'm doing when I'm teaching, if you just kind of draw a box around that, that'll help you understand those are the 2 terms. And you're going to factor on this, okay? So look at these 2 boxes. What do you see that's the same? 2x minus 5 the second, 2x minus 5 the first. Which one comes out?
X plus 1.
Lowest exponent. What else? X plus 1, x plus 1. Which one comes out? Second power. Okay, so what you want to do next is this. Okay, you want to go through and write that common factor. Now 3 and 4 don't have a common factor, so don't worry about that. So we'll have 2x minus 5 to the first, and then x plus 1 to the second, and then you can draw like a big bracket. Okay, like that. Now let's kind of figure out in your mind how this works. You got to think, okay, what do I multiply this by? So it turns into this. What do you need?
3.
You need a 3. What else?
2x minus 5.
This is a first power. That's got to go up to a second power, right? See, that already matches. You need a 3 and you need one more of those.
Wait, so how come you took away the second power again?
Okay, because you always work with the lowest exponent when you're dealing with common factors. See, x plus 1 to the second and to the third are the same factor, but you work with the lowest exponent. If you took the 3 out, you would end up with a negative exponent, and you don't want to do that. Okay, so what would go here? That would be a 3, and what else do you need? 2x minus 5 to the first. We'll see, make sure it's right. Multiply it out. Make sure it's right. Okay? Now, what do you need to get this second box?
4.
You need a 4. What else?
Plus 1.
Okay, x plus 1 to the first. Okay, tell me if you understand. This is the part students have the hardest time with, is this right here. Okay, it's factoring and algebra background stuff. Now see, look at this. Everything matches. You got a 3. Now you have those 2 things. The 1 and 1 adds to 2, and then you got that. Okay, that's the way you got to understand this. Then you got, when you multiply this times this, you have the 4. You have this matching up now the way it's supposed to, and then the second power times the first power is the third power, like that. Okay? All right. Now what you got to do from here is you need to work this out, and once you get that done, then you're done. Now that right there shouldn't be too bad. You got distributive property and collecting like terms, so you want to go ahead and finish up that way. And you don't need these first powers. Okay? So I'm doing that to emphasize something. Okay? Now inside this bracket, you're going to have 6x minus 15. Then you're going to have 4x plus 4, like that. Okay, collect like terms, and then we're done. So we have 2x minus 5. That's a factor, x plus 1 squared. And then here we would have 6 and 4 would be 10x, and negative 15 plus 4 would be minus 11. That's your answer. That's your goal, is to make it all the way there. Okay? Now, like I've been saying, you get a lot better with algebra when you start studying calculus. You see what I mean? Okay? You're kind of taking things to a little bit higher level. Is there any part of that algebra that I need to help anybody with? Okay, you're not going to know until you start working problems out, that's for sure, okay? All right, that'll wrap us up with that then, and we're going to go on to this